Thank you everyone for joining us today. I want to talk a little bit about the latest advances that we've had in GridGain in the last version, which is 8.8. So basically, this is our newest version, and it has some interesting additions in terms of features. And I just would like to give a little bit of an idea of why we added those features and what kind of value they add to the overall product. And I will, of course, talk about every individual feature as well, giving just a brief description of what they do. And we will also have a couple of demos as well to show you how that works in action. So with that, let's get started. I'm sure many of you are familiar with what Apache Ignite is, what the Apache Ignite memory computing platform is, and what GridGain is. But just to recap, I wanted to give a quick overview of the technology. So basically, this is the memory computing platform, or essentially a memory-centric database, which can be used for a wide variety of use cases. Essentially, Ignite is kind of a combination of distributed data storage, both in memory and on disk data storage, with a comprehensive set of APIs and processing capabilities on top of it. That includes compute grid, which essentially allows you to execute any arbitrary code, service grid, which allows you to deploy services along with the data. We have key value APIs, which are traditional for distributed caches and like data grids. We have SQL, which is very robust and including like DML, DDL, and all the different querying capabilities like joins, group bys, order bys, and all that. Transactional support is also available. We have some streaming capabilities, event listening capabilities, and even like a machine and deep learning library built on top of the compute grid and the data layer. And you can also integrate it with external data storages as well. Again, if you have like a caching or a data grid use case, you can put it on top of a relational database or a NoSQL database that you are currently using for your applications and get some acceleration from that. So it's basically kind of a generic platform for providing scalability and performance to your applications. At GridGain, we also provide some additional features on top of it, mostly for enterprise deployments, production mission critical deployments. These are the features like data center replication, which allows you to replicate the data across multiple data centers. Snapshots and recovery, which is essentially like a database backup. So if you're using GridGain as a system of record, you can create those backups periodically and then recover if needed. Advanced security, rolling upgrades. So basically any features that are typically required by production mission critical deployments. And we also provide services, support both for Ignite and for GridGain products. So even if you're using Ignite, you can use our support as well. So that's just a recap of the technology. Now, what it can be used for? Again, like as I mentioned, it's kind of a very generic platform that that covers a wide variety of use cases, right? It can be used for simple caching, or as a data grid solution, meaning that you have a database which presumably you've been using for your applications for some time. It can be a relational database, which is probably the most typical case, like Oracle, Postgres, or MySQL, or something like that. Or it also can be like a NoSQL database, Cassandra, MongoDB, or something similar. And you want to deploy Ignite on top of this database to accelerate the applications. So this is basically what that's kind of the starting point of Ignite, I would say. So that's how Ignite started, as a caching platform or as a data grid platform. Nowadays, you can also use Ignite or GridGain as an actual database, with the addition of the persistence layer, which I will talk in a little bit more detail in a minute. We basically, you don't need the external database anymore. So you can just deploy Ignite and get a distributed multi-tier database that stores data both in memory and on disk, and use all those different APIs and processing capabilities on top of that data. This provides multiple advantages. Obviously, you don't need an external database, so you don't need like to maintain two different technologies and integrate between them. And also it provides some, performance and functional improvements as well, which I will be talking about. So this database use case and database approach is kind of newer to Ignite to a certain extent. So there are still a lot of development going on in that regard, and 8.8 is actually quite a milestone in terms of capabilities that database provides. So, and I will of course cover that in detail. So, in terms of advantages that the persistence layer provides, again, it basically provides you with some additional deployment modes that you can use for your applications, right? Like essentially with external database integration, we can have those pure in memory data storage that you can still deploy, or you can integrate with an external database, and that's the kind of memory modes that deployment modes that we had prior to introducing the persistence layer. With the persistence layer, again, you can use Ignite as a database, and one of the biggest advantages of that is that you can have either full data set in memory, in which case your persistence layer is just a pure, used purely for persistence, meaning that it's just used for recovery. If something goes wrong, the cluster goes down, you can recover from disk, right? But you can also have a subset of data in memory and a full data set on disk, which means that you can also use that for different hybrid workloads where you have historical data sets which are quite large to store in memory, and then you can put them on disk, having like your hot data sets that are accessed frequently in memory. That allows you to kind of balance between the performance and the amount of memory that you need to use, and essentially the cost of the deployment. And with native persistence, with Ignite persistence layer, this happens transparently. Because with external database, you will have to do a lot of manual work to achieve the similar functionality. You will have to manually move the data back and forth based on certain criteria, load it into memory, and then run queries on it and all that. With the native persistence, this is not required. Everything is transparent in the sense that you just use the APIs and Ignite will figure it out automatically for you. So in memory tier, essentially consists of Java heap and off heap memory. And Java heap is used for like operational purposes. When you execute a query, it will fetch it into heap and do some processing there. And off heap memory is the actual data storage, so it can be much larger. The whole purpose of it is to avoid GC pauses, and that essentially allows us to store large amounts of data in memory. And this can then be scaled out, of course, across multiple nodes. So native persistence is essentially like an additional layer of data storage, right? So we have the in-memory layer, and then we are adding persistence to that. The way it works is that whenever you write something into memory, it will actually persist into write-ahead log. And then the write-ahead log will be checkpointed to partition files that actually store the data. So again, you don't have to store all your data in RAM at all times. So if you have large data sets and you feel like there's no need for all that data to be in memory, you can have only a subset of that data in RAM, and it will always be fetched into memory if needed, if you request that data from Ignite, and that will happen automatically and transparently for the application. The way it works is it's always based on the page memory architecture. I'm not going to go very deep into detail like how it works internally, but essentially the idea is that all the data and metadata that we have in Ignite is split in fixed sized pages, which is like 124 bytes by default, or no, it's 4K by default, yeah. So all the data is split in pages, and the pages can have different purposes. There are like index pages that can then have links to the actual data pages that store key value pairs or like table rows essentially. There's also like metadata, some metadata that is stored in the same way. And then all those different pages can be transparently replicated into memory and into the disk layer, right? So whenever you actually request some data from Ignite, whether you use SQL API or you use key value API, what Ignite will do is it will map the data that you are requesting to a page ID or page IDs if that requires fetching multiple pages. And then it will use its own internal mechanisms to figure out where this page is, or to be more precise, whether it has this page in memory or not. And if it is in memory, then it will just read from there. So there is no need for there's no need to go on disk, and therefore you get very fast performance. But if it's not there, it will go to disk. It will locate it in a proper file, fetch it from there, and put it into memory and return the data to you. So again, this is kind of that's what we have created in the course of like several last 2 or 3 years or something. We kind of reworked the whole architecture to enable this database use case, right? So now you can use GridGain as a database, as a system of record without need to have an external persistent storage for that purpose. And yeah, by the way, all that comes with strong consistency and distributed transactions across both layers. So if you run transactions, those transactions will spawn both in-memory layer and persistence layer, regardless of what your configuration is. Whether you have all the data in memory or you have a subset of data in memory, you will always get strong consistency in terms of asset transactions. And as I've mentioned before, if you're using GridGain Ultimate Edition, you can also utilize the snapshot and recovery capability to create essentially full database backups or incremental backups that you can use to restore the data in case of some operational error or software error. This also can be used for diagnostics, because essentially you can create a backup of your production data, let's say, and recover it somewhere else on a smaller cluster, maybe to do some research or something, which is quite convenient. So all this creates a good foundation for this kind of database use cases. And as a matter of fact, Ignite is being used by many companies in that capacity, but we've been definitely missing some of the important pieces. And these are the enhancements, or at least some of them. There are more to come, as a matter of fact, in the future, but we are covering those. We're currently essentially covering those gaps that we have. And 8.8, as I said, is quite a big milestone in that regard, because we've had a whole set of features that are quite important for database use cases. So let me go through that and just briefly over several features that we've added in this release. So the first one is advanced disk defragmentation. Essentially, what happens is that whenever you add something, if you're using GridGain prior to 8.8, what will happen is that whenever you add something and then to the storage, whether it's you do an insert into a SQL table, or you do a put, like a key value put, and then remove it, it will be marked as a removed entry, essentially, in this page memory architecture, but the actual disk space will not be reclaimed, which is not an issue in most cases because this space can be reused. But this creates defragmentation in this page memory architecture, in those memory segments. And essentially, you can come up in end up in a situation when the pages are so fragmented that you cannot insert certain entries in those fragments that are there. And in that case, Ignite will have to create new pages and therefore extend the file sizes. And there is a possibility that you will end up using all the disk space that you have, which is obviously the situation you don't want to be in. So what our customers and Ignite users used to do is basically do some manual defragmentation, which could be achieved by doing a rolling restart and then like manually removing fragmented files, which was a decent, used to be a decent workaround, but obviously it's not very usable, and we wanted to improve that. And for that, we provided some advanced tooling and some advanced mechanisms for this kind of defragmentation to allow users to automatically shrink those files and reclaim space in case of defragmentation. Essentially, from the user's perspective, we've just added a couple of commands into the control.sh tool, which is kind of a command line utility used for this kind of purposes. And those commands allow you to perform this defragmentation at any moment in time when you want to do that. But again, the only difference would be that the major difference would be that you don't have to manually clean up the files, or try to figure out which files are fragmented and which files are not fragmented. Ignite will do this for you. You just execute those commands and everything happens automatically. So this is first one, which is more of a kind of usability improvement rather than a new feature, but still it's quite important because it was one of the pain points again for this kind of database use cases. The second one is memory quotas for SQL. So again, this is more of an improvement rather than a new feature, because again, one of the possible issues that our users could face prior to 8.8 is that Ignite could go out of memory in case of certain query execution. So since the way Java works, we don't control Java heap directly, right? And we don't really know when the garbage will be collected. We don't really know how the memory will be allocated there and all that. So for heavy queries that require a lot of data to be processed in memory, we couldn't really stop JVMs from going out of memory, essentially, in this case. But all we can do is we can limit the amount of data fetched from off-heap space to the Java heap, and that's essentially what memory quotas are. This functionality allows you to specify certain limits for the amount of RAM used for SQL query execution. So let's say you know that you have 16 gigabytes of heap memory per node, and therefore you can specify that for SQL you will use only, let's say, 12 of them, right? That will guarantee that Ignite will never use more than 12 gigabytes of RAM for SQL execution specifically, which in most cases basically makes it much less probable that you will go out of memory. And those quotas can be specified both on per node level. That's basically what I've just described. You specify, like the total amount of memory used for SQL. Or you can do that on per query level as well, meaning that for a certain query, like if you know that this particular query can consume a lot of memory, and maybe it's kind of quite a unique situation for you, and you don't want to have this global limit, but you want to limit this particular query, you can do that as well. And the way it works is that if it goes out of memory, if it goes beyond this limit rather, you actually have two options. You can either force Ignite to just terminate that query, and in which case you will just get an exception. Or you can also offload to disk. That obviously has, performance implications. Query might become slower because it has to use the disk for just to store this temporary, result set for the duration of this particular query execution. But it still will work, and you will be not running out of memory, and you will get correct results. So the choice is yours. You can either just terminate the query and get an exception in this case, or you can offload those temporary results into disk for further processing. So the next item is data compression. This is a brand new feature which we have introduced. This is fairly straightforward. It's just data compression. It allows you to compress the data within the nodes, both on memory and on disk, and essentially allows you to significantly reduce the amount of space used for the data. It is dictionary-based compression, meaning that on every node, Ignite will maintain a dictionary, and all the repetitive entries and repetitive data will be compressed, and Ignite will consume less data this way. Of course, it has performance implications. So there is a trade-off between performance and the amount of RAM or disk space that you will use, that you will need for your data. So always be, careful with this. I would not recommend to just blindly use this feature, but in certain cases, this is definitely useful. And you can also, which is cool. But what is cool is that you can use that on per data region basis or per cache basis, essentially. So you can have some of the caches compressed and some of the caches non-compressed. So if you have you have a huge historical data set, for example, which you don't really access too frequently, and just there for historical purposes, maybe for some rare reports that you want to generate, then it definitely makes sense to compress it. You don't have a lot of performance concerns there, but you do want to consume less space with that data set. Then using compression for that part of your data is definitely useful. If there is a very hot data which is relatively small, then probably you should not compress it. So you should always consider that. And the final one is data encryption. Again, one more brand new feature that we have. Again, it's quite self-explanatory. It just allows you to encrypt the data that you have. For any cache, you can essentially just enable encryption, in which case all the data on disk will be encrypted, right? And all those data files that you have on disk will not have any non-encrypted data, right? So if your storage is compromised and those files are leaked in some way, no one can read the content of those data files. The configuration is very straightforward. All you need to do is configure, is provide some basic configuration and essentially configure the key store. And then for any cache, you can set the encryption enabled property to true, and that's all you need to do basically. At this point, everything that you put into that cache will be encrypted based on the basic encryption configuration that you've provided. All right, so let's see some of that in action. So I will start with a quick demo for the compression feature. So let me open the code. So this is like a very simple demo of of the compression functionality that we have. So let me go first through different items that we have here, just for you to understand what is going on. So first of all, I'll open the POM.xml file, which configures the dependencies for the project. So I actually have two dependencies here. And the first one is important because that's the GridGain compress module. So essentially, compression is enabled in GridGain, is essentially provided as a separate module. So whenever you want to use compression, you need this GridGain compress module to be enabled. So if you do that in Maven, that's how you do that. You just need to provide add the GridGain compress dependency here. And I will also have the control center agent dependency. That's just for me to be able to use control center, which is our GridGain's management tool for Ignite. I will use that to monitor what is going on with the data consumption and all that. I'll show that in a second. And I also have a single class here, which is my main application class, which basically does a very simple thing. First of all, it starts a couple of nodes right here within this JVM just for test purposes. So everything runs on my laptop. Activates the cluster, which is just a initial step that we need to do after nodes are started. And then we create a couple of caches. So first one will be a compressed cache. And here we can actually see how it's configured. So all we need is provide this entry compression configuration here, and compression will be enabled at that point. We're using default configurations, but there are some parameters that you can tweak as well here. But that's the minimum that you need to do to enable compression. And the second cache is just regular cache. It doesn't have any compression. And those caches are located in different data regions. I will just use that for monitoring purposes. I will show you how much data is consumed by every region, so that we know how much benefit compression gives us in that case. And then it just, after the caches are created, it just starts loading the data. We have this person class, which is very straightforward. It has name, it has a company, and just an additional string, which is basically like a payload. And it creates those person instances, with certain randomness, one of two names, one of two company names, and also one of those 4 different strings. So as we can see, like those person instances, they're all going to be different, but at the same time, we should expect a lot of repetitiveness here, right? Which means that compression we might expect that compression will give a good benefit here. So and we'll see how much improvement in terms of space consumption it will provide. So after the creation of the person instance, it isn't sorted into both caches. So those two caches at any moment in time will essentially have the same amount of data and the same data set essentially, but one will be compressed and another one will not be compressed. All right, so let me start it up. So this will probably take like 30 seconds or something. And yeah, this basic configuration, essentially all it does is, hold on. Yeah, essentially all this does is just create those data regions that I've mentioned, one for a compressed cache and another one for the non-compressed cache. It's called the ordinary cache. And we have persistence enabled for those data regions, and we also have metrics enabled for both data regions as well. All right, so I think it is started. Yeah, so we have two servers, which is expected. So we have our cluster up and running. So I will use this link. So it actually prints out the link for the GridGain control center, which is cloud-based. So we can go to this control gridgain.com, and this token is used to connect to this particular cluster. So I will go to the browser and just open this link. All right. So it's currently loading the data, and it's actually remember the metrics that I've configured for my previous run. Basically, the control center is a tool that allows you to create different dashboards with different widgets for different metrics. So I can like click at widget here and essentially add any metric to the charts here, which is quite convenient. In my case here, I'm showing the off-heap size. Essentially, like we're measuring the off-heap space, and we're looking at how much how many bytes are consumed there in the off-heap space. And I have it 2 times for the compressed cache data region and for ordinary cache data region. So the one at the bottom is not compressed. The one at the top here is compressed, and it shows it for both nodes. So these are 2 charts are for 2 different nodes. So, and as we can see, let's take a look at what we have here. So for some reason, difference is not that big. I think it kind of takes a little bit, it takes a while, it looks like, to load the data. Probably because I'm running all the GoToWebinar software and everything. The expectation here is that we should have like 30% difference or so for this data, for this particular data set with the like this repetitiveness characteristics that we have. Yeah, it kind of goes slow, but we even with that, we can see that it, we have like here we have 52 and 46, and here we have 47, 39. When we have more data loaded, because we have more and more repetitive entries going in, the difference will obviously grow. So yeah, I will not keep you waiting, but basically the demo is available. So this code will provide a link to the demo code so that you can run it on your own, and check what you get in your runs. And also there is a video on our YouTube channel where one of our engineers also does exactly the same, and you can also see that how that works. So with that, again, just to the whole point here is to emphasize like how easy this is to configure, right? All we need to do is provide the entry compression configuration, and Ignite will take care of everything else. It will create all the dictionaries internally and will compress the data for you. And if you have this kind of data set that has a lot of repetitiveness, definitely should consider that. All right, so with that,
hey Val, just
yeah.
very quickly on compression, Craig had a couple of questions. Do you want to hit that? His first question is just how much slower will a query be if the data is compressed?
I don't have any numbers, to be honest. So obviously there is a trade-off between those two things. There is no way around this. I would say it kind of depends on the actual case, and the best way to figure this out is to measure it. But as far as I know, we've had some testing as well, and I can check on that. I don't have any numbers with me right now, but I can look it up and maybe provide later somehow.
And I was thinking that the comparison there is like the reason you compress data is to avoid making trips to the disk, right? So the comparison may be compressed in cache versus stuff that you need to retrieve from the disk. But again,
that's one of the purposes, right? Yeah, I mean, you're right. Well, one of the purposes that you might have is to better utilize your RAM storage, and therefore essentially have more data in memory and go to disk less frequently, right? But in certain cases, you also want to just have this data set to consume less space, in the sense that this is not a data set that you frequently access, right? Maybe this is a historical data set that you just want to consume less space and therefore make your cluster cheaper, not spend too much money for that data set in particular, right? But either way, there is a trade-off between performance and the space used for a data set, of course. So
yeah, and then Craig mentions there's other use cases too to compress, especially when you use third-party vendors and APIs that have rate limits. So yeah, some interesting use cases for compression. All right, shall I switch to Mirza?
Yeah, sure.
My name is Mirza Aliyev. I'm a software developer at GridGain, and today I'm going to show you how to encrypt your data at rest by running a simple demo. So this class is placed in Ignite repo in examples module, so you can easily find this class by searching its name and play with that code by yourself. So let's run the example, and I'm going to explain what's going on here. So first of all, we start the cluster. After that, we create cache named accounts cache, which will be filled with bank account data. Bank account data is a simple class with fields account name and balance. After that, we restart our cluster and lowering our cache from the disk and printing its data to the log. So let's check what happened here. So we can see that cluster is started, cache is created, data is populated, and cluster is restarted. And at the end, we can see that data that is loaded from the disk successfully printed to the log. So let's check that data is not encrypted. To do that, let's go to the console and find the partition file which is associated to the cache. To do that, we need to go to work folder, db. Here we can find the folder which is connected to the node. And here we can find the folder with our cache accounts data. And here is a partition file. So let's open it. To see that file in a human readable way, we need to switch Vim to the hex mode. So let's do that. Sorry. So let's try to find our data. So you can see that data is presented here. So it means that we can easily find it by searching it on our disk, and data is not encrypted. Let's see how to enable encryption. To do that, we need to, first of all, we need to switch it on by setting special flag called encryption enabled to true. Also, let's rename our cache to encrypted accounts caches. And also we need to change our cluster configuration and provide encryption SPI with key store encryption SPI with provided key store path, key store password, and master key name. So let's rerun the example. And I'm briefly repeat what's going on here. So we are starting cluster, creating cache, setting encryption enable to true, put some data. After that, we restart our cluster, loading our cache from the disk, and printing its data. So let's check. So we started our cluster, cache created, related, and data is successfully printed. So let's check that data is encrypted at this time. So to do that, we need to go to cache encrypted accounts data folder. Here we can find partition. So let's open it. Again, switching to the hex mode. So let's try to find our data this time. So you can see that it's impossible. So we have shown that data is encrypted. To sum up, we have learned how to enable encryption for your cache data and how to make your cluster more secure. So thank you for your attention.
Yeah, thanks, Mirza. Great demo. Yeah, so with that, we actually can, we can answer any questions if you guys have any. So, and there are also a couple of events coming up. One is the developer training, which will be held by Dennis Magda, who's our VP of marketing. And another one is more of a kind of a use case review from one of the Ignite users. This will be a session as a part of our virtual meetup. Feel free to join if you're interested. These are quite interesting sessions.
All right, so let's move on to the questions. Maybe there are some. Let's start with. There was some general questions, Val. One was about automatic backup and recovery feature.
Mm-hmm.
Can you maybe walk through what editions have that feature? There's Ignite, there's Community Edition, the different versions of the software. So can you perhaps walk through which versions have that capability?
Oh no, that one is yeah. I mean, I don't remember exactly which version we've added it in, but it was quite a while ago.
Okay.
Any version that you can download currently will come with snapshots. The only thing it's a part of GridGain Ultimate Edition. So GridGain essentially provides 3 different editions of the platform, which is based on Ignite. That's Community Edition, which is essentially which is an open source product based purely on Apache Ignite. It doesn't have any additional features for the most part. Maybe there are some, but they're all open source anyway. So, but it's more of a GridGain's version of Ignite. I would put it this way. We use it for maintenance, for better support, so that we are able to provide fixes faster and these kind of things. Then there is the Enterprise Edition, which adds most of the enterprise features that I've mentioned before. Rolling updates, data center application, security, and the whole set of our other features are a part of Enterprise Edition. Most of the enterprise deployments, especially if these are like data grid deployments or cache-based deployments, that they can use Enterprise Edition. And Ultimate Edition provides the snapshot and recovery feature, and now it also provides the compression feature. So if you're using it as a database for larger data sets, then Ultimate Edition is likely your choice. So it's so again, like in terms of which versions provide the snapshot and recovery feature basically all of them. 8.7, I mean, it's been there for quite a while, but it's part of Ultimate Edition. So Enterprise Edition doesn't have that capability, and Community Edition obviously doesn't as well.
All right, great, thanks. A next question from Himadri is, are there any performance benchmarks with respect to two-phase commit with Ignite persistent storage on?
Yeah, sure. There are transactions. I mean, we're running like a whole set of benchmarks, essentially for every release. We do that for regression and just to verify that there are no drops or anything. I mean, the actual numbers. I mean, again, we use those numbers for comparison, right? We compare one version with another, and just to make sure there are no drops and there is no regression or anything like that. The actual numbers for like your use case should be obtained by running just benchmark on your data set and on your particular transactions that you have, because like it might vary quite drastically depending on the data model and what kind of transactions you have. So yeah, we certainly do run some of the benchmarks, and I think some of them are even published, and I can also look it up and provide some links if you're interested. But it's always like the best way is always just to measure your own application and your own workloads, your own patterns in terms of how they work, especially with persistence, because with persistence, it might imply that you have all the data in memory, or maybe you don't have all the data in memory. That also can affect the performance. So that's also something to consider.
Yeah, that makes sense. Maybe one question on encryption, I think. How does key rotation work?
Mirza, do you know the answer to this question in particular? But
so there is two kind of keys that you have: the master key and cache key. Cache key is key for encrypting data cache, and this is like cluster level, and users not have the do not have the option to see that key, but it's possible to rotate master key and cache key. So there are some commands. You can do it like in Java API or CLI API. You just need to provide the new name of master key, and this key will be taken from your Java key store, and a special task will be provided for changing that master key. And also for cache key is kind of complicated, kind of difficult process, because you need to also re-encrypt your data, but it's that synchronous task that will be after you want to rotate your cache key. But like basically it is.
So essentially, we have some commands on the control sh tool, right? That
Yeah,
allow
you can do it like on Control-H or Java way.
Okay.
Awesome. Great. Thanks, Val and Mirza. That brings us to the end of the Q&A section and to the end of the webinar. Thanks, Val. Thanks, Mirza. Thanks, everyone. Have a good day.
Yeah, thanks everyone for coming.